Okay, so I got the lathe in position. One of the things that I needed to do is get the three-phase converter going, so I mounted that onto a mobile cart. I'm not sure where I'm going to permanently place it. The lathe itself did have a bad contactor, so I had to order a new one. Unfortunately, the ones originally made on the right here, you can't get those anymore. So I ordered a larger one, physically larger, same capacity, but it doesn't fit in here. As you can see, I've just got it wired in right now. I'm going to have to rewire this board to get all of those mounted, but I wanted to wire for testing. What was happening, and I knew this when I checked it out, is that when you went from the forward position to off with the lever, right, it would keep running. Right? If you use the e-brake, it would keep running. So that's basically the contactor that stops everything. So that one was bad. It would buzz, and every now and then it would catch. So as you can see, here it is, and it is pretty smoked. I don't know if I can get that to focus any better. Let's see. There we go. It had some heat go through it. So I put that new one in. We got the three-phase converter here, all set, wired up. I got the three-phase breaker panel on the back, and I'm going to temporarily hook this up to three-phase power to see if that new contactor fixed it. Okay, there we go. Start it up. Okay, that's running. See, that's off still. Okay, good. Off, off, off. All right, there we go. That was forward. Have it in neutral. I didn't want to do anything yet. Chuck's not in. Oh, nope, still not turning off. All right, must have a bad switch here. But that contactor isn't buzzing anymore. Okay, there we go. Go ahead and turn everything off. Motor's running. Everybody's happy. Yay! Okay, here we are again. Make sure we're powered on. Yep, can hear the contactor engage. Reverse works fine. And we keep tripping that breaker. Damn it. Shouldn't be doing that. Okay, so I feel kind of silly about this. We're going to put this in neutral. I thought I was on a 50 amp circuit on the panel at the other end. I'm actually on a 40 amp circuit, and I'm going to take you around the back and show you why that kept popping on me. Okay. So, what we've got here on the panel, if you look, this draws 21 plus amps on three phase. But since we're going from single phase to three phase, we essentially have to double that. So it's going to draw about 42 amps max. So I'm a 40 amp breaker back there. All right. So if I put in a slow blow breaker for motor startup, that probably would solve that. But really, this will be on a 50 amp circuit. Actually, technically, that's going to be on an 80 amp circuit when it's done. This is all just done right now for testing. So what I'm going to do is put the spindle in neutral, so we'll avoid that big load. And we'll go ahead and put it in reverse here. Turn everything on. There we go, reverse. Now the motor's spinning up. I hope you can hear that. Go ahead and turn it off. Okay, motor spins down. Perfectly fine. So now we'll go forward. Hear the motor spinning up. Boom, and I bring it back and nothing. Look at that. Now we'll come over here, watch this. Turn the power off. I'm gonna hit the E-stop. That motor is still spinning. There should technically be no power going to this unit. So what I found out, oh, it just kicked out on us. So what's happening though, is this unit, that contactor with the light on it, this one, is the one that controls the forward direction. It sticks. So that'll have to be replaced. But more than anything else, somebody has probably wired this wrong at some point in the past. I wired this new contactor in, mirroring what was already in there. That's the main power contactor, right? So even if this is sticking, when I turn the power off,
there should be no more power to the motor. That main power contactor should just cut all power to the entire rest of these circuits. So I think that somebody's got something crisscrossed where this contactor is self-energizing through a power tap. So once main power is on and that's engaged, somewhere there's a loop being created that is getting power even though the main power contactor turns off. So what I'm basically going to have to do is diagram this. There is a diagram on the lid here, but it is so covered in oil and difficult to read, I doubt I'll be able to find anything. This particular model Victor lathe, I can't find any information on. I've contacted the company, haven't heard back from them yet. The 18 by 40 doesn't appear to exist. There's literally no documentation, reference to it on the internet, nothing. There's a 17 by 40, but not an 18. It appears functionally the same, so I probably can get the documentation from that to reference it. So let's go ahead and turn this off. De-energize. Come over here, turn the rotary off. There we go. So yeah, so what's going on? Originally I thought it was a contactor problem on the main power contactor, that it was sticking. Replace the main power contactor. It's not what it is. I found out earlier that if I put it in reverse, come back here and take it out of reverse, that this contactor was still engaged. And if I smacked on it with something, you know, my pen, really, I just gave it a few hard whacks and that popped back out and it stopped. So we know that we have a contactor issue, that it's sticking, but it's also self-energizing. So that's dangerous. That is, if power were to cut off, this machine could potentially come back on engaged. I'm not sure why. I completely had the power cut off. This was stuck on. So if it is in a self-energizing loop and that were to stick, when power returned, this machine could start unattended. That's unbelievably dangerous. So we're going to have to change that out. So I'm going to search for some documentation on this and see what we can find. And I'll come back with my follow-up. Thanks. So that contactor, this one here, with the horrible contacts inside. They were so pitted, it was unbelievable. There's some pictures I think I have. I'm going to see if I can add them in here. I was able to take the contacts out, clean them up sufficiently on a diamond stone that I had to put them back in just to check function, and it's no longer locking in the forward position. So it definitely was this contactor that's an issue. This unit is old and very obscure. I can't find any documentation on it. Contacted the Victor company, haven't heard back from them, but they don't seem to have anything anywhere on the internet. It's another one of these group of Taiwan-made lathes that were in the same pattern by any number of manufacturers. So hopefully I can find something out there. But in looking at this, none of this, of course, is available today. You can't get any of these part numbers, these pieces, but they're all based on specifications. So when I had this out, I was able to get all the specifications for it, research, find out what I needed, and then doing the cost analysis of replacing them all. This one I had to replace. The original one was bad. It's the one that was overheated. So I was going to replace additionally this one, these two, the overcurrent for the motor. You know, this is a motor starter assembly effectively. In looking at all of that, it just wasn't cost effective. It was going to cost, I don't know, somewhere in the neighborhood of $300 just in parts in here, and then having to rewire the whole deal. So what I started doing is tracing all of these wires, and here's my notes, if you can see these. I don't know if that'll come up on the camera, my rough notes here. So this is all just meters, testing, continuity, all these bits of things to figure out where each of the wires in the front goes, because what they have is back here these labeled wires 1 through 8 on red wires that go up front. Those wires up front don't have any corresponding labels, so had to find out what all the levers did, what went where. Let's get around the other side here. Here we go. Let's take the cover off, got in here, was able to determine what wires did what, make a small adjustment to the limit switch while I was in there because the handle was a little loose. Got that all done, and in the end I came to the determination that I am definitely not going to replace these contactors. So I'll have you hang on for a second and go over and look at what I did. All right, here we are, and we're looking at a LePond 7.5 kilowatt VFD. There we go, wired up. This is going to replace all the controls on the lathe, but I'm going to wire it in where the original buttons and controls and knobs all work instead of using this control panel. I want to have this back out of the way. I like using the original controls on the lathe. I'm used to them. I don't want to have to wire a whole new control panel, all these other things. So I'm going to rewire this, and that'll be another part of the video as to what's going on. Right now, I did hook it up temporarily to another project that I don't have footage of yet, but I need to grab. So I have a VFD coming for this. I've replaced my small Porter cable air compressor. The head is over on the workbench. It was a 2 horsepower, 3 horsepower, something like that, 5 CFM. So plumbing it in, running all PEX, all the way through the shop, all the way around, and I replaced it with a 5 horsepower 3-phase motor and a new head at a little over 15 CFM. So I throw the VFD on here just to test the whole process, pressure test all the lines, everything. Everything's working fine there. Did find out that this wheel is unbalanced, so I'll have to do that, but it's a teaser for another video. But we're going to be putting this VFD on the lathe over there, so that'll be next in the video series, I think.